Space debris is affecting in particular ESA missions in low Earth orbit because these orbits are the most densely populated. ERS-2 and NVSAT are just flying at the most critical altitude, and this is also the altitudes where the past collisions have been taking place. So we have to make sure that our own satellites do not produce additional debris. That we do by implementing the mitigation measures that ESA has defined and made applicable for ESA missions in April 2008. And that means for future space missions we would have to make sure that we limit the orbital lifetime of our satellites to 25 years in the low Earth orbit region. And for geostationary satellites, we would have to reorbit them into a graveyard orbit. We would have to passivate our objects in order to make sure that we do not have accidental explosions. And we would have to do collision avoidance, which we actually already do for NVSAT and ERS-2. That means we need to monitor conjunctions and fly avoidance maneuvers if necessary.
When the shuttle goes to station, we'll dock and then we'll turn the entire station shuttle stack backwards. For most of the mission we'll fly that backwards, which reduces the risk to the high temperature areas, the thermal protection system on the shuttle. So it greatly reduces the risk for loss of vehicle for the shuttle. It slightly increases the risk to the station. But at the end of the mission it will turn around, fly normally, and the station goes back to normal, and the shuttle will depart. The overall risk is much lower that way. The risk increase with station is more than offset with the risk decrease with the shuttle. And we worked with the international partners to make sure that everybody was aware of this change and why.
ESA is starting a very important new activity, which is called the Space Situational Awareness, or SSA program. And this SSA program comprises several important domains, such as space surveillance, including also space debris, space weather, and near-Earth objects. So the principles which have been taken to implement this program during these 3 years, and then with a wider perspective, longer perspective over the 10 years, will be to, first of all, use and federate what already exists at national level. Secondly, to develop what is missing yet from the existing facilities and capabilities. And thirdly, once we have established a European capability, also to really focus and develop what exists already today in the area of international cooperation. We do cooperate extensively with the United States, but also with other space powers, Russia, China, India, especially within the frame of international organizations such as the UN COPUOS, for instance.
We have ended right now the 5th European Conference on Space Debris. In fact, we have started off with the first one in 1993, and at that time we tried to understand the problem. In the following conferences we tried to find ways to cure the problem, to find a remedy on decreasing the number of objects which we release into orbit. Now we found that after we understand this problem very thoroughly, it's not sufficient to do debris mitigation on those assets to which we have direct access, that is operational satellites and operational upper stages. We have to do more in the future. We have to actively remove passive objects, dead satellite, dead upper stages from orbit in order to conserve the environment in the long run. This is a major finding of this conference, and this is a major message from this conference.